problem involves a system of blocks. One is resting on an incline at an angle. The coefficient of friction between the block and the board is 0.7. It is connected by a non-stretchy massless string, which goes over a pulley and connects to this block. This block is freely hanging down. There is no friction between these surfaces. It's not actually in contact. And the angle between the incline and the horizontal is 31 degrees. So what we'd like to know is the acceleration of the whole system. First thing we have to do is analyze the forces on each of the blocks in turn. So the free body diagram for this just this block by itself will be the force of gravity pulling it down and the force of tension pulling it up. And we don't know what the acceleration of the block is. Both blocks are 15 newtons. So this is 15 newtons also. The forces acting on this block are a little bit more complicated. We have the force of gravity pulling it down, which is equal to 15. We have the support force going up perpendicular to the surface. Remember, the support force, or the normal force, is the perpendicular component of the force of the surface on the object. We have the tension going this way, and we also have force of friction. Now, we're going to have to guess which direction these blocks are going. It doesn't matter whether we guess correctly as long as we're consistent between this block and this block. So both blocks are equal weight. This one's being pulled up a board. I'm going to guess that the blocks are accelerating this way. That's my prediction. And if that's my prediction, then if it's going this way, the force of friction is going to oppose that, so it's going to be back this way. Okay. Now let's call this block A. And this will be block B, because we'll need to designate that in our formulas here. We're going to have to do possibly 4 formulas, but probably fewer since we know that there's no x component here. So let's start with our green block, our block with the green arrows, our blue block actually. And using our first condition for equilibrium, the sum of the forces in the y direction equal m a y, and that will equal tension, which is going up, minus force of gravity on block A, which is going down, and our acceleration, if we say the block is accelerating downward, it's speeding up in the negative direction, so we need a negative sign here for our acceleration. Now we know the force of gravity on the block is 15, but for our formula we need to know what the mass is. So 15 equals mass times 9.8, because we're just looking for a magnitude. So our mass will be equal to 1.53. So negative 1.53. We don't know what AY is. We don't know what tension is. But we do know that FGA is 15. So we have an equation with 2 variables, which means we need at least 2 equations to solve. Let's go to our other block now, and since most of the action is happening in the x direction, let's start with our x equation. You'll see that we end up needing to do both, but we'll start there first. So in this case, the block is speeding up to the left, which is the negative direction. So our acceleration will be negative. And the forces will be, T is in the negative direction, friction is in the positive direction, and then gravity, we're going to have to divide into components. And let me just draw my gravity triangle up here so you can see it a little bit more clearly. This will be 15, which is Fg. This will be Fgx, and this will be Fgy. Now, to show you how I get the 31-degree angle in this big triangle to relate to my little triangle, I'm just going to draw a diagram below here so you can see what's happening. Let me use my triangle tool. Alright, here's my first triangle. Let's see. So, the hypotenuse of this triangle right here is the force of gravity. Here's my y component, and here's my x component here. This angle, we said, was 31. We'll call it theta. Alright? Get rid of those lines. Okay. Now, look at this triangle right here. This is a right triangle. This is the right angle. If this is theta, this must equal 90 minus theta by our basic triangle rules. This right here is a right angle. This whole angle right here is 180. I've used 90 up here, so I have 90 left. If this is 90 minus theta, then this must be theta. So the top angle in this triangle will be equal to the angle of the incline down here, and this, remember, is our right angle because it's the angle between the x and the y component, which is always 90 degrees. So let's go back up to our little triangle. We can now put 31 right there. Okay. So we know that there's also a component in the x direction of gravity, which is going to the right, so that will be positive. Now let's substitute in what we know. We know the mass is 1.53. We do not know what the acceleration is. Minus, we don't know what the tension is. We don't know what the force of friction is, but we do know that there's a relationship between the force of friction and the normal force because they're both components of the surface on the object. So I'm going to replace FF with mu Fn because I know mu, and I think I can find Fn plus Fgx. Fgx is opposite to the 31-degree angle, so sine 31 is Fgx divided by 15. So if I move 15 over to this side right here, I can put in 15 sine 31. And that's just a number. I can multiply that out. So look at that. We've got a lot of variables there, And this Fn is really kind of sticking out. Fn is a vertical force, so let me write out my vertical equation for block B. Sum of the forces in the y is equal to, now my mass is still 1.53, but my block is not accelerating at all on this plane. So my acceleration here is equal to 0. I'm liking that because that's going to make my math easy here. Fn is up, so it's positive, minus fgx, which is going down, and that's adjacent to the side. So cosine 31 is equal to fgy divided by 15. I move my 15 over to this side, so I get minus 15 cosine 31. This whole side is 0. I can move this over. And this is 12.86 newtons. So, I know what Fn is. Let's go back up here and see if that helps us out. 1.53 AX equals negative T plus mu from over here is 0.7, 12.86 plus 7.73. This is going to simplify a lot. I'm not quite done yet. But if we rewrite this one more time, and let me put that in the calculator, I get 16.73 for all of this right here. Now I have two equations with an A and a T, and an A and a T, and remember the acceleration, as long as it's on the same string, and the tension, as long as it's on the same string, are equal. So I'm going to drop my x and my y for my subscripts. Now, to make the signs easier, I'm just going to multiply this whole equation through by negative. So I get 1.53a equals t minus 16.73. So I haven't changed the equation at all. Now, let me combine them down here because I need a little bit more space. So I'm just rewriting the top equation here, and then I'm going to combine it with this equation right here. Now, since I would like to know the acceleration, and I don't really care about tension, I'm going to eliminate the tension by moving 15 over to this side, and then taking this expression and plugging it in for t right here. Okay. Now I've got two a terms and two terms without any variables, so I'm going to move my a's to the left and leave my other ones over here. Let me just put that in the calculator. So I get 3.06a equals 1.73 negative. And then I'm going to divide both sides by 3.06. And I get negative 0.57 meters per second squared. Now, that will be the magnitude of my final answer, but the fact that it's negative takes us back to our picture. We assumed in the beginning, because we had to have a direction for our acceleration, that the blocks were going this way. Because we got a negative answer, we know the blocks are actually going this way. So that's what the negative tells us in our answer, and that is the magnitude of our final acceleration. If we'd gotten more than negative 9.8, we would know that our answer was not reasonable and that we'd made a mistake somewhere along the way.